loop functions are some of the most powerful functions in the R language, and they make it kind of very easy to use, especially in an interactive setting. The idea behind a loop function is you want to execute a loop over an object or a set of objects in a way that's kind of that does a lot of work in a very small amount of space. That way, you don't have to type as much on the command line. Of course, we already learned about loops. We know about for loops and while loops, things like that, and those are all work very well. However, they are kind of less compact in a certain way. So there are a couple of loop functions in R, and they usually have the word apply in them somewhere. So some of the key ones are lapply, sapply, apply, tapply, and mapply. And the real workhorse function that I'd like to talk about here is lapply. And the idea behind lapply is that you have a list of objects and you want to loop over the list of objects and apply a function to every element of that list. And so it's a very general concept, and it can be used very powerfully to do a lot of computation in just a little bit of typing. sapply is a variant of lapply that simplifies the result. Apply is a function that operates over the margins of an array, so this is very useful if you want to take summaries of matrices or other or higher dimensional arrays. Tapply is short for table apply, and it applies a function over subsets of a vector. And mapply is a multivariate version of lapply. So I'll go into details about how these work in a minute. There's also another function called split, which doesn't actually apply anything to objects, but it's often useful in conjunction with functions like lapply or sapply because it splits objects into subpieces. So lapply. Lapply takes three arguments. Basically, the first argument is a list, which is called x. The second argument is a function, or the name of a function. And then there are other arguments that can be passed through the dot 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 argument. And the dot 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 argument is used to pass arguments that go with the function that's being applied to each of the elements of the list. If x is not a list, then it will be coerced to a list if possible. If it's not possible to coerce the object to a list, then you'll get an error. So the lapply function you can see is very simple. The code for it is right here. Basically, we look for the function. If the object is not a list, then it's coerced to a list using as.list, and then the rest of the lapply function is implemented internally in C code to make it a little bit faster. So the idea with lapply is that you're going to take this list of things, and remember, a list can contain any number of different types of objects, so they could be vectors or matrices or data frames or whatever it may be, and you want to apply a function to each one of these elements of the list, and that function is going to return something. It may not be the same thing that it originally was in the list. So, for example, it may take as an input as a vector, but then it may return a scalar as a result. So the function is going to return something for every single object in that list, and the return values are going to be assembled in a new list, and that's what lapply is going to return. So lapply, it's key to remember, it always returns a list. What goes in may or may not be a list, but it will be coerced to a list, and what comes out will always be a list. So here's a simple example. I'm creating a list with two elements. The first one's called A, and it's a sequence from 1 to 5. The second one is called B, and it's 10 normal random variables. So now what I want to do is I want to loop over this list of two elements and apply the mean function to each of those elements. So you can see that when I call lapply on x and I apply the mean function, I get another list back, and notice that the list has the same names as the original list, A and B. But now I've got the mean of the first element and the mean of the second element. And so that's how lapply works. Here I've got a slightly more complicated list. I've got 4 elements. And I'm calling lapply to each of those elements, and I'm getting the mean of each of those elements. So now I've got a list with 4 elements. The names are preserved, and notice that, of course, each of the elements of the original list was a vector of a numeric vector of some sort. But what I'm getting back is a vector with just a single number in it for each element of the list. So here's another way to call lapply. Here I'm creating a sequence of x 1 to 4, and I'm calling runif, which generates uniform random variables using random number generator. Now, the first argument to runif is the number of uniform random variables that you want to generate. So if I say runif1, it's going to generate a single random variable. If I say runif2, it's going to generate a vector of 2 random variables. So here I'm applying the runif function to the sequence 1, 2, 3, 4. So what I'm going to get is a list where the first element is a single random uniform. The second element is going to be a vector of 2 random uniforms. The third element is going to be a vector of 3. And the fourth element is going to be a vector of 4 random uniforms. And so you'll know if you know the runif function, you'll know that it has other arguments to it beyond the number of uniforms to generate, but those other arguments have default values, so I don't need to specify them. Now suppose I wanted to call the runif function on each one of these elements of x, but I didn't want to just generate a uniform between 0 and 1, which is the default. Suppose I wanted to generate a uniform between 0 and 10. So now I need to pass some arguments to the runif function which are not the default values. In particular, I need to change the max value. So I can do that with lapply by passing these arguments through the ... argument. So here I'm calling lapply on x. I'm passing it the runif function, but then I'm specifying that I want the min to be 0 and the max to be 10. So now when the list that I get out of this has random uniforms that are between 0 and 10. So lapply and the associated functions make heavy use of what are called anonymous functions. Anonymous functions are functions that don't have names, so you don't assign them a name of some sort, but you can kind of generate them on the fly. So here's just a quick example. I'm going to create a list that contains 2 matrices in it. The first is a 2x2 matrix, and the second is a 3x2 matrix. So you can see the list here. There's 2 elements. They're named A and B. And suppose I want to extract the first column from each one of these matrices. So what I can do is I can call lapply. So there's no function that out there that already extracts the first column of a matrix. But this is easy to do. You can just write a function that just takes the first element, the first column of that matrix. So here I'm going to call lapply on x, and I'm going to write the function right here. So I'm going to say function, and then I'm going to give it an argument, and then given that argument, I extract the first column. So here, when I call lapply with this function, I get the first column from A and the first column from B. So this function doesn't exist except within the context of lapply, and after the lapply function is finished, the function basically goes away. So that's an anonymous function because it doesn't have a name. And lapply and a lot of these other types of functions use anonymous functions very heavily, because unless there already exists a function that does the operation that you want to do, you're going to have to write the function kind of on the spot. So sapply is just a variant of lapply, and all it does is it tries to simplify the result of lapply if possible. So recall that lapply always returns a list, but sometimes you don't want a list. Sometimes you want something different. So for example, if the result is a list where every element is of length 1, then what sapply will do is that it'll return a vector of all those elements. So usually you don't want a list where every element is a single number, for example. And so sapply will simplify that into just a vector. If the result is a list where every element is a vector of the same length, for example, if the list comes back and every element has a length 5, for example, then what sapply will do is it will put those elements in a matrix that's 5 by however long the list is. And so that's often what you want to happen. But if it can't figure out how to simplify the object when it comes back, for example, if the object has many different types of things that come back, then it won't do anything. It'll just return a list. So here in this example, when I called lapply and I applied the mean to everything, what happens is I got a list back that's of length 4, and every element of the list is a single number. And so it'd be a lot nicer if I just got my list back that was just if I just got a vector back with all these numbers in it. And that's exactly what sapply does. So sapply called on x with the mean function gives me a vector with 4 numbers in it. Of course, if I called mean on the list by itself, that's not really going to work because mean is not meant to be applied to lists, and so you'll get a warning message with NA back.